Hello again, welcome to this other video on factoring. We're still on this topic, but we're finishing it today. So today we will talk about two cases, the double factoring case and the general trinomial. Spend a little more time on the general trinomial because it has a little more meat around the bone, but we still should take a little bit of a look at double factoring. So what's double factoring? So what is double factoring? Double factoring occurs when you have four terms. These are the situations we will encounter the most often. So double factoring, you need four terms. Let me give you an example, and then you'll see exactly what the meaning of double factoring actually is. So example 1, 2.5 stars, factor completely, the usual wording for these questions. Factor completely, I have something here, x3 minus 3x2 plus x minus 3. So you can see here 1, 2, 3, 4 terms. The double factoring actually refers to factoring them 2 by 2. So we must actually factor out something common to the first two terms and something common to the last two terms. Let's see what happens if we attempt to do that. So what would be common between x3 and minus 3x squared? Well, there's an x in here, so the smallest power is 2. We've seen that before. We're going to take out an x2, right? Taking out an x2 from an x3 leaves me with x. Taking out an x2 from 3x2 leaves me with minus 3. Good. Yes? Now, let's see if we can do the same with the last two terms. Nothing in common here except a 1. So I will take out a 1. What will I have left if I take out a 1? Well, I'll have x minus 3. Now, the success of double factoring resides in having the same term in this bracket as in this bracket, because then we're going to do what? We're going to refactor out the x minus 3. So now, if I take a look at this term and this term, what do I see as a common factor to these two guys? Well, they both have a bracket x minus 3, so out with it. Out with the bracket x minus 3. What shall I have left if I take away x minus 3 from the first term? X squared. And here, plus 1. And this is now completely factored. So, not a very difficult technique. Just remember that if you have four terms, it's a double factoring situation that occurs. All right, so perhaps we hike it up a little bit. Another example, factor out completely. What shall we have now? So example 2, 3 stars, factor completely, x3 plus 2x squared y minus 4x minus 8y. All right. So once again, 1, 2, 3, 4 terms. So let's see if we can do our little thing and factor 2 by 2 by collecting whatever might happens to be common to the first pair and as well as the second pair. So what's common between x3 and 2x2y? Certainly an x2, right? So x3 divided by x2 is x. 2x2 divided by x2 is plus 2y. Good. What is common to minus 4x minus 8y? Well, I would say minus 4, right? Minus 4, take away minus 4 from minus 4x. Take away minus 4 from minus 8y, so that's plus 2y. And once again, success. Why? Because this guy here is the same as this guy there. So as long as this happens, we can refactor, n'est-ce pas, the x plus 2y outside. So x plus 2y, factor of x squared is left here, and minus 4 is left there. Is that fully factored? Take a second look. The answer is not quite, because x squared minus 4, as we saw in the last video, is a difference of squares. So this will have to be written as x plus 2 and x minus 2, because x squared is a perfect square, and so is 4. That is now our final answer. C'est bon? Not super hard. Okay, so I wanted to start with this because we're going to need double factoring when we deal with the last case, the general trinomial. At least we'll need it sometimes. Maybe not every time, but certainly it will pop up and it will be a useful technique to have. Okay, so general trinomial. General trinomial is something of the form ax squared plus bx plus c. The purpose here, as usual, is to be able to write this sum and difference into the product of two brackets. That's what we mean by factoring, right? We know that. So how do I actually do that? There are several approaches. I believe that perhaps the simplest and probably most widespread of these approaches is the so-called product sum approach. What is the product sum? It's a good method to actually help us find the factoring of this when the numbers involved are a little large. When the numbers are like very simple, then the product sum is really not that useful. For example, let me see here, exemple 1 for this section, 2.5 again. So factor completely. I have something here that is fairly simple, x squared plus 6x minus 8. Many of us will look at this and say, I don't really need a method to actually factor this. That is, I can do something called trial and error. What is trial and error? Trial and error is, okay, I need to kind of educatedly guess what goes into these brackets. Because this is an x squared, I'm going to have an x and an x here very simply, because when I do x times x, I have x squared. Yep. Looking at 8 here, 8 is either 1 times 8 to 2 times 4. And this is where the trial and error comes in. Suppose that I write 8 as 2 times 4, so that 2 times 4 is actually 8. Now, it's not really 8 that I have, it's minus 8, right? So what is it that I actually need? Oh, I think I made a boo-boo here. Why don't we put a plus here instead of a minus? Because I just realized that with the minus it doesn't work. Did you see this? If you saw this, you're very good. So basically, I want to know what are going to be the signs that I should be putting in there so that when I FOIL it out, I get back to this. Well, clearly, 2x plus 4x is 6x. So that's one, I would say, fairly trivial way of factoring guys like this, by just playing around doing the, trial and error sort of thing. But there is a more structured method called product sum that actually says you need to find two numbers whose product is this guy times that guy. So the coefficient of x squared times the constant term. In here the coefficient of x squared is 1 and the constant term is 8. So the product is 1 times 8, which is 8. And the sum has to be the middle term. the b. So the coefficient of x, which is 6. So now we're looking for two numbers whose product is 8 and whose sum is 6. So what are the product? What gives you a product of 8? What gives you a product of 8? 1 times 8 and 2 times 4. Right? There are no other pairs that actually work. Which of these, if I combine them, will give me a sum of 6? Well, clearly, plus 2 and plus 4 gives me a sum of 6. So the two numbers that I'm looking for are 2 and 4. What do I do with these? Haha! What do I do with these once I have those two numbers? Remember that we are trying to factor this guy. So what I'm going to do, I'm going to keep the first and keep the last. And I'm going to replace 6x with those two guys. So plus 2x plus 4x. And then what am I going to do? I'm going to do double factoring on this. Take out an x from this guy, x plus 2. Take out a 4 from that guy, x plus 2 as well. Once again, you got the same guy here, like in the double factoring we saw, so take it out. That's x plus 2 times x plus 4. So this is the same answer as the one we got there. That was much quicker, but the numbers were small. When the numbers actually get bigger, the product sum method is a pretty good fallback plan. So I'm going to let you basically use whatever method that you want on this. It's going to be up to you. I'm not here to rewrite how you do things. I'm here to give you the tools to actually solve the problem. So trial and error is definitely one way, and product sum is a little bit of a more organized way. So let's see if we can do another example here. So factor completely. Why don't we get rid of this? We don't need it no more. Hey, we don't need that heading anymore. So example 2. Let's hike this up a little bit to perhaps 3 stars. So factor completely. Factor completely the following trinomial: 6x squared minus x minus 12. So it's a trinomial because it has 3 terms, clearly. And the purpose of the exercise in the end is to come up with this expression written as the product of 2 brackets. So how can we do that? Here, the trial and error approach might be a little cumbersome. If you're really good at this, then you can just play with the numbers and put them in. But for most people, the product sum approach is probably a good way to look at this problem. So product, looking for 2 numbers whose product is 6 times minus 12, so minus 72. And those 2 numbers should have a sum of the coefficient of x, which is minus 1. So basically what I'm going to do there, I'm simply going to list the factors of 72. What is 72 equals to? So it's 1 times 72. And then it's 2 times 36. And then it's 3 times 24. And then it is 4 times 18. 5 doesn't go. It is 6 times 12. And 7 doesn't go, and it's 8 times 9. And after that, we get back to the 12 over here. So this is the list of all the factors of 72. I didn't put any signs yet. We can deal with this when the time comes. Now the question is, you want to add these guys in such a way that you're going to get a very small differential between them of minus 1 in that case. So 72 minus 1 is 71, too big. 36 minus 2 is 34, too big. 24 minus 3 is 21, too big. 14, too big. 6, too big. 9 minus 8, perfect, it's 1. That's the winning pair. 8 and 9. Now let's play with the signs. we need the product of these two numbers not to be 72, but to be minus 72. So one of these has to be negative, right? Not both, because it would get a positive answer. And the sum must be -1. So what are my two numbers? 8 and -9. Let's verify this very quickly. 8 times -9 is -72. 8 plus -9 is -1. We got our two numbers. What do I do with them? Well, I'm going to replace the middle term, which was -x. I'm going to replace -x with my two numbers, 8 and -9. Doesn't really matter in which order you bring them in. Plus 8x minus 9x. Notice, I know it's pretty obvious, but I'll still say it because sometimes I like to say obvious things. 8x minus 9x is just really another way to write what we had there, minus 1x. We haven't changed anything really, we just rewrote it. Okay, so this having been done, we're now going to do double factoring because we have 4 terms. Okay, what is common between 6x squared and 8x? Well, certainly, what, 2 goes in there, right? And x goes in there, that's for sure. So if I factor out 2x from 6x squared, I will get 3x. 2x goes into 8x 4 times. And the second pair, minus 9x minus 12, what is common? 3, oh, even minus 3. Take out minus 3 from minus 9x, that's 3x. Take out minus 3 from minus 12, that's plus 4. And we have a winner. Why do we have a winner? Once again, because the content of this bracket is the same as the content of that bracket. As long as this works out, we can refactor the bracket that is common. So I refactor. Now, this is what I do, right? Now I look at this and I ask what is common to both. Clearly the bracket is common to both. That's the way we wanted it. And that's 2x minus 3. And now that factoring is complete. And that's my final answer. It cannot be factored any further. All right, so that's your standard general trinomial. I want to make a little bit of a remark here at this point. So let me just get rid of this. I know that some of you may have learned in high school, yet again, another approach to that, which actually uses, so alternate approach quadratic formula. Does that ring a bell? It's going to be a useful formula in this course. We're going to be using this in several places. So quadratic formula is like this. X, the answer to basically this is equal to 0, is minus b plus or minus the root of b squared minus 4ac over, remember, 2 times a, right? This quadratic formula can actually help us factor out guys like this. Keeping in mind that, as we mentioned before, coefficient of x squared is a, coefficient of x is b, constant term is c. What I have here is that a is 6, b is minus 1, and c is minus 12. Okay, so I'm going to put that into the formula and see what I get. So x is equal to minus b, so minus 1, plus or minus the root of b squared, so minus 1 squared, minus 4 times a times c, all of that over 2 times a, which is 6. Wow. So what do I do with this? What's the meaning of all this? Well, minus 1 is 1. plus or minus. That we have to actually be careful. We have to do that in order. So first the square, minus 1 squared is 1. And then the multiplications. 4 times 6 is 24. 24 times 12 is 288. And a plus and a plus, that's plus 288. Divided by 12. Okay, good. So what is this? This is 1 plus or minus the root of 289 divided by 12. Now what is the root of 289? If you said 13, it doesn't work. If you said 15, 225. If you said 17, 17. 17 is the ticket. So x is equal to 1 plus or minus 17 over 12. You remember what we do with this? We actually break this up into two answers. One with a plus, one with a minus. So 1 plus 17 over 12. And 1 minus 17 over 12. So my two answers for x are actually 18 over 12 and minus 16 over 12. That can probably be simplified a little bit. What's common to 18 and 12? I do believe that 3 goes into these one. Actually 6 goes into that. That can be reduced to 3 over 2. And here this is minus 4 over 3. Now you may wonder at this point, what do I do with these numbers, right? What do I do with these numbers? Well, how do these numbers help me factor the original trinomial? Well, using those, I can do the following. I can do x minus the first answer multiplied by x minus the second answer, and I will have something that resembles the original polynomial. What I'm saying is that x minus 3 over 2 times x minus 4 over 3, so x plus 4 over 3, is something that actually resembles the original thing. But it's not the same, is it? The coefficient of this, x times x, is 1x squared, while the coefficient of here is 6x squared. So whenever we do the quadratic formula on this, here's what you have to keep in mind. Whatever the coefficient here in the original polynomial is, has to come in front of that. So the final answer, so this is not the final answer, this is an intermediate answer. So the final answer I will put here. So the final answer will be x minus 3/2 times x plus 4/3. And then I'm going to keep in mind that this coefficient has to be present in the final answer. Otherwise, this is never equal to that. But it will be exactly equal to that should I put a 6 right here. Absolutely. Now, I'm going to prove to you that this is the same answer as the one we had before. Why? Well, 6 is 2 times 3, yes? 6 is 2 times 3. So let me write 6 as 2 times 3. And let me rewrite this string of multiplications as 2 times x minus 3/2 multiplied by 3 times x plus 4/3. Bring the 2 in. 2 times x, 2x. 2 times minus 3/2 is minus 6/2 is minus 3. And here, 3 times x is 3x, and 3 times 4 over 3 is 12 over 3 is 4. Ah, there it is. That was the answer we had obtained before using the product sum approach. So if you feel comfortable with this, go ahead. You can use it. I find that for me, it's more like a last resort method. I like product sum as a more efficient method than the quadratic formula, but it's nice to show a couple of ways. We also have trial and error, which is kind of, again, a third way when the numbers are not too big. Good, 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 good. Let us do perhaps one last problem that will summarize what we have learned today. Where's my sheet? So factor completely. This is example 3. We're going to keep this at 3 stars. So let's change the variables here. 20a squared b plus 36ab minus 8b. This is definitely, it looks weird, huh? It's got like more letters than what we are used to, but it is a general trinomial. Pourquoi? Well, 1, 2, 3 terms. So it's a trinomial. Can't seem to actually go right away into my strategy here. I think this requires a little bit of cleaning up before we're allowed to go on. Let's see, can we factor something that would happen to be common to all of these 3 terms? 20, 36, and 8. What goes into all of these? 4 goes into 20, 4 goes into 36, 4 goes into 8. Let me take out a 4. So 4 I will have 5a squared b plus 9ab minus 2b. Is that all that I can take out of this? Is there something yet common again between the first, the second, and the third? Look carefully, they all have a b. So I'll take out a b, and then I'll have 5a squared plus 9a minus 2. And that actually brings me back to familiar territory. That is your standard trinomial. So how do I do this? Well, why don't we practice a little bit our product sum strategy. Product 5 times minus 2. Looking for 2 numbers whose product is minus 10 and whose sum is 9. So what is 10? 10 is 1 times 10, and it is 2 times 5. Don't have a lot of choices here. So clearly, the 1 and the 10, if I combine them with the proper signs, will give me minus 9. So what are my numbers? I will need plus 10, and I will need minus 1. For the product of plus 10 and minus 1 is minus 10, and the sum of 10 and minus 1 is 9. So we use those 2 numbers to replace the middle guy. So we will replace the middle guy 9a by 10a minus a. And then if we did our work correctly, this should work out nicely. So here's 4b. Now I need to, what's common with this and what's common with that as well. Alors, what's common between 5a squared and 10a? I can see a 5a in here. So 5a, I shall have a plus 2. And what is common between minus a and minus 2? Well, only minus 1. And that's a plus 2 as well. Once again, same thing here, same thing there. We got a winner. So that's going to be 5a minus 1 times a plus 2. Doesn't really matter the order in which you write those terms. Multiplication is commutative. And there it is. Final answer for this guy. So once again, we'll do a couple more examples, perhaps a little more involved when we meet in class. But for now, that gives you the gist of factoring. And this is like a very important tool, especially for the first part of calculus called limits. There's quite a bit of factoring involved here. So good thing to know, like they say. In the meantime, take care. I'll see you soon. Ciao.